Hello and welcome back. This is the video to understand recursion. In this video, I wanted to go over the following 10 problems which can help you understand recursion better and help you to solve problems using this technique. So let's understand recursion first. Recursion means defining a problem in terms of itself. So if we look at the standard Fibonacci sequence, the nth term is given by the sum of the previous two terms, which is this formula. Now f is the Fibonacci number and which is the problem that we are defining as defined in the statement. So this nth Fibonacci number is defined using the same problem which is itself, but the variables present in the subscript are different. So this is what recursion means from a broader perspective. Now let's understand it in terms of mathematical representation. Next up, as we saw in this previous diagram, we defined the Fibonacci sequence as nth term using the sum of the previous two terms, as was this formula. Now in this formula, the subscript that is present in the function is known as a state. So we are representing the problem in terms of a state, which is n minus 1 and n minus 2 as given in this formula. This is called as a state. Now next thing is to look at transitions. So the nth Fibonacci number is computed by taking the sum of previous two Fibonacci numbers and they are added. So the transition from nth state to n minus 1 state, or going and returning the value from n minus 1 state and n minus 2th state, is known as a transition. So to compute the value for the nth term, we need to know the value for n minus 1 term and n minus 2th term. That is known as a transition, which means change of state from one to other. Next up is base case. As we know, the Fibonacci number is 0 and first is 1. Now these are the fixed values because this equation must terminate somewhere and we need to know what are the values which we need to consider whenever a case like this occurs. So this is the terminating condition and we need to plug in some values here. So those will be 1 and 0 respectively. These values are known as the base cases, and these must be known in a literal format for every relation or formula like this. Next up, we need to know what we're actually evaluating by taking the reference to the transitions. So in this problem, we had two transition states, which was n minus 1 and n minus 2, but let's say the problem is to find out the factorial of the nth number. So as we know, n factorial is defined as n times n minus 1 is factorial. If we represent this in terms of a formula, so factorial of nth number is n multiplied by the factorial of n minus 1 number. This is the function that we're evaluating and n is the state. And as we know, the factorial consists of products of numbers, hence this is an evaluation of product. But if you saw this formula, then this was an evaluation of sums. So nth term was sum of previous two terms. As you see here, this is a sum. But in this case, it was a multiplication. So depending on different problems, we will evaluate different operations on the transitions of the functions. Next up, let's understand how this is going to substitute for all the values. So if you keep on substituting this will end up with n multiplied by n minus 1, again multiplied by the factorial of n minus 2. This will again eventually be converted into n minus 2, then n minus 3, and so on until we reach a base condition, which is f of 0. Now 0 factorial is defined as 1. So as you see, recursion will basically substitute the values and compute the product by unrolling the function one after the other. And the main thing that happens here is the change of states. So depending on different problems, this value substitution will work differently, as we saw in the Fibonacci equation and the factorial representation. That is all about the terms that we need to be familiar with for understanding recursion. Now let's move on to the problems. So this problem states that we are given an input n equals to 5, and our function needs to print the numbers from 1 to 5 in this manner only. So this is the input to the function. So we will now this function has access to 5, but since we need to print 1 first, we will not print it initially, but we will say that call the function for the previous state, which was f of 4. But that is not what we want to print right now. Then we call f of 3 and so on until we reach the first number that we want to print. Whenever we reach the first number, which would be the last case when this is true, at that time this function would be called on f of 0, but this particular execution would not happen because this is only valid when n is positive. Hence this would terminate without printing anything, and whenever we will return back to this statement, and at that time we will print 1. Now the execution for this block is over. It will return to this state again and calling the print statement that was left, and this will eventually print 2, and unwinding it one after the other, we will end up with the printed sequence as 1, 2, 3, and 4, and 5. So this is how the approach would look like. To understand it better in terms of functional representation, so initially we are calling a function which has two jobs to do, which first one being calling the next function and printing the value. So let's suppose the state of a function is defined like this. So initially n equals to 5, and it had two jobs, right? The first one to call the function, after which call the function f of 4, and once it is done, then print 5. And since f of 4 needs to be computed, then it will call f of 4 here and would be 4, and this depends on f of 3. And after f of 3 is done, it will print 4. This will continue, and we will eventually have the last state n equals to 1, and nothing needs to be called from, or f of 0 needs to be called, but it would be terminated. And the first job that this function does after the next function is called is print 1. Now once this job is complete, which is printing 1, the caller which was the previous function to this, where n equals to 2, it will understand that this function is completed and the job for this needs to be executed after that, so which is printing 2. And eventually, one after the other, all this would be done. Since this is the order in which we are calling this recursive functions, that's why whenever first is completed, after that only the next task is executed, which is printing the number to the output. And this would be the final solution. If you wanted to print in reverse order, so for 5, 4, 3, 2, 1, in that case, only thing that we need to do was swap these two lines, so that whenever we have access to the last element, we need to print it first. In that way, if we swap these two lines, we will get the required result. Next problem is to find out the sum of the array elements. So to understand this in terms of recursive formula, we need to understand how we can decompose this array into smaller parts and represent the problem in terms of itself, as we saw in this definition. So if we are given an array, let's say 1, 2, 3, and 4, then finding out the sum of the entire array is same as taking the first element and asking for let f of f be the sum of the array. And this would mean we need to find out the sum of the rest of the array. So this is the state. And these are the transitions. And this value is the first value of the array that is passed as a state. So we are given a state, and if eventually this would become empty, in that case nothing, empty array means a sum of 0. That means we can return 0 from the function. Else we need to take the first element of the remaining array and pass on the array, which is except the first element, which would be by taking the slice from the next one. And this would come to the array sum. So if you unwind this, you can eventually see that this will unwind to 2 plus 3, 4, calling the function on 3, 4, and so on. And this would mean we are taking the sum as it is from the array. And it is important to know that the we must follow whatever the function expects as a parameter and returns as a value. So this function that we are going to write will not store the answer as in any variable or run a for loop over this given array. This function must return a value in terms of representing the problem in terms of itself using recursion. So that is the point of this solutions. There are obviously simpler approaches, but to understand recursion, these are the practices that we need to follow. Okay. The next problem is to check palindrome. So we need to check whether string radar is palindrome. To check whether any string is palindrome, we need to perform the following operation. We will check the first and the last element. If they are equal, then we can move on to the second and the second last, and so on until these pointer L and R are less than each other. And if at any point they are not equal, then that means that is not a palindrome, and we need to stop the iteration or basically say that return false from that case. So in this case, if all of them are true, and this is a palindrome. So to define the problem in terms of itself, we need to know the pointer of iteration that we are currently at. So initially we are given the entire string, which means the pointers are L equals to 0 and R equals to n minus 1, where n is the length of the string, and we will check the first and the last character of that string. And this AND is for checking that all of those conditions are met, the first and the last, as well as second and second last, as well as third and third last, and so on. Hence, this AND is the transition, as we saw in the definitions. These are the evaluation value as we saw in this slide. And the rest of the string is the string from L equals to 1 to R equals to n minus 2, which is same as this part right here, which will be passed to the next state. And eventually, if we have a string of length 0 or 1, it would be 0 when the string length is even. So if we had a string like this, in that case, eventually the iteration would stop at the case where S is empty. Or if this was the input, in that case, the iteration would stop at the case where S is the only character T present. And in both of those cases, the string is palindrome, and we can return true from there. Okay, that is it. Let's move on to the next question. Next, we need to find out the factorial of a number. The formula, as we saw, could be defined as the n factorial as n multiplied by the factorial of n minus 1th number, and simply this can be translated into a recursive function where n is the state. And notice that we are passing n, and this is a product. Hence, we need to multiply the values, and the base condition is that f of 0 is 1. So if we reach this case, we can simply return 1, or else we need to compute the answer using this formula. That is it about this. Next up is to find out the sum of digits of a number. Let's say we are given a number like 1, 0, 2, 0, 3, and we need to know the sum of digits. So the function, whenever this function returns the sum of digits, which would be 0 plus 0 plus 3, which would be 6 in this case. So to define the problem in terms of itself, we are given n as an input to the function, and this function returns the sum of digits of n in the base representation. Okay, so one thing to notice is whenever we have a number like 1, 0, 2, 0, 3, we can know the last digit by taking the modulo with 10, and the rest of the number by taking the division by 10, floor division by 10. Hence, the problem can be represented in terms of itself by finding out the sum of digits from right to left. So f of n can be defined as the last digit, which would be n mod 10, plus the rest of the digits, which would be f of n by 10. So this is the reconciliation or functional representation of this problem, and that is what we need to translate. So initially n would be 1, 2, 3, and f of 1, 2, 3 would first compute 3, which would be the last digit, plus the rest of the number. Then f of 12 would be 2 plus f of 1, because we are computing the last digit, adding it to the sum and returning the function value from there, and so on. And this would be 1 plus f of 0 here, and we will handle the case where n is 0 separately by saying that f of 0 is 0 as a base case. Hence, this problem represents the function as follows. So this is the last digit, and this number is the floor division of n by 10, which represents the remaining digits, except the last one. And this is sum of digits, hence we need to take the sum of digits individually, and we have handled the base case as well. That is it. Next, we have to count the set bits in a number, which is similar to the previous problem. We are given a number in decimal representation in base 10. Suppose n is 1, 2, 3. Let's not take 1, 2, 3, but let's say 7 in base 10. This would be 1, 1, 1 in binary representation. And count set bits, let's say f of n is the count set bits in n, count of set bits in n. That means this function should return the expected result. And to represent this in terms of itself or the solution to the problem that we are solving, we will use the same technique as we saw previously. We will take the last digit of the binary representation, which would be n bitwise with 1. So this will give the last digit in the binary representation of n. This is because, let's say you have a number like this and you take an n with 1, which would be this value. This would return 1 only when the last digit is 1, and this would return 0 whenever the last digit is 0. And that is what the individual summing denotes. So this is the last digit in the base 2 representation of n. And the rest of the number is the number when it is shifted one place to the right, which is same as f of n right shifted by 1. Or you can also say this value is same as n by 2, the floor division. These both are the same. And this is how we represent the problem in terms of itself and the solution to our problem. Base case is again that whenever you shift a number, eventually it would become 0. And in that case, there would be no set bits, and f of 0 would be 0 in that case. So if we translate this in terms of code, the base condition is when n is 0, we return 0, else we find out the last digit using bitwise and the rest of the some of the set bits, which would be, so counting set bits is same as summing sum of digits in n's binary representation, which would be base 2. And the rest of the digits is same as n by 2 floor division. Next up, we need to find the minimum and maximum in an array. So if we have an array like 1, 2, 3, 4, and 5, to find the minimum, we will check the first element and minimize it with the rest of the array. So first, the minimum is either first or present in the rest of the array, which would be, let's say a is the input to a function which returns minimum or maximum. Then the minimum is either the first element or the element or the elements after that. And this is how we arrive at a function which returns the minimum or maximum where array is the input, which is what we have done here. We initialize the array and finding the minimum and maximum using these functions. So we are passing array as input. Whenever length is 1, that means there is a single element in that array, and the maximum could be the first element in that array or the maximum in the rest of the elements remaining in that array, and we would maximize the answer using that. That is it about this. Next, we will go over this problem, which is to generate all subsets of a given array. So suppose we are given an array like 1, 2, 3. And to generate all the subsets means to generate a result like this, which would be empty set or individual ones, or two pairs, or the two pairs like 2, 3, and so on, or the entire set. This is what a subset represents, and there are 2 raised to 3 subsets possible for this array. In general, it is 2 raised to n, where n is the length of the array. To generate all the subsets, we essentially have 2 choices for each of these elements. So suppose we had the elements as 1, 2, 3. So we had 2 choices, either to take this element or not. So this had a choice to take or don't take, and the same for the other ones. Now, subset is choosing any combination of these choices, and we need to go over all combinations. This is what generating a subset means. Now, the first choice, as we saw, the input to the function is the array, and we will essentially change the state of this array by introducing our choices. So these are the choices, 2 choices available to us for each element. Now, if we don't want to include the first element of this array in the subset that we are currently generating, so we are generating this sequence, which is a sequence of take or don't take. Suppose this is what we want to construct, right? And we will eventually have 2 choices for at any position from 1 to n, and we need to make a choice for the first element at this functional state. In this state, we need to make a choice for this element. So we'll have 2 choices. First one to don't include it, which would be generated by taking the rest of the array, which would be this part, and the second one by taking the first element. Next, we'll make the choice to include that element, which would be the element 1, in all the sub-arrays which are possible from the rest of the part of the array, which would be done in this part. So this is a subset, and we need to merge it with all the subsets that are possible without taking that element from the rest of the array portion. And this we need to combine it into a single list. That's why we are considering all the subsets without the first one, and all the subsets by taking the first one and merging them with all the subsets without taking it. That way we'll go over all the combinations and generate all the possible subset for the array. Next up, we have a problem to find out the nth Fibonacci number, which is a simple one. So f of n is defined as f of n minus 1 as f of n minus 2. And this is a problem where we don't need to think anything. The formula is already given, and we just need to implement the solution. And the base condition is also clear. Whenever n of 0 is 0 and f of 1 is 1, which can be translated into code as follows. Except we have a slightly difficult problem. So in this problem, we need to find out what is the maximum value that we can achieve by taking some items. So we have n items. Each of them has a weight of I, and some value as value 5. And we have a knapsack which has a capacity of this value, let's say C. And we need to choose some of these items so that their sum of weights is less than equals to the capacity of the knapsack. Some of the weights of the items that we have chosen should be less than equals to C. So over all the possible choosings of these items, we need to maximize the sum of the value of the chosen items. And this is what the function that we're going to write should return. So this is the return value, and these are the constraints that we need to follow. Okay, so this problem is same as the problem that we saw to find out the subsets, just that the subsets are also having their own preconditions. So as we saw, we have two choices to generate a subset for the array elements. So suppose we have n equals to 4 items, then we would have 2 raised to 4 choices to generate a subset. But in this case, the valid subset could be different, not exactly equal to 2 raised to 4. Now, any combination of this would result in a subset, and we need to go over a valid subset. To go over the valid subset, so suppose we write a function which returns the maximum value that we can achieve, and we start by making the choice for the last item, which is index n. Okay, so there are two choices, either to take it or don't take it. If we take it, in that case, suppose we take the last item, in that case the capacity of the knapsack would decrement by the weight of that particular item. So the last item would decrease the capacity. Hence, it is important to store that capacity after making a particular choice as a state. So we are passed in the initial state, or the maximum capacity of the initial knapsack, but if we make some element in the knapsack, add an element in the knapsack, the capacity decrements by the weight of that particular item. And if we keep on making the knapsack smaller and smaller, this would eventually make it 0 or less than 0, which would be considered as a base case. Now, to understand what we are actually computing, we want to find out the maximum sum of values of the items, right? Hence, this function must return sum of values, and we need to maximize it over all possible values. Now, whenever we arrive at a base case, whenever we don't have any more items to process, which would be arriving at this state, then we can return 0, stating that we don't have any more choices to make, and the choices that we have already made are valid ones, and you need to consider this in the subset to find out the best possible answer. Now, to make the first choice, by saying that we will consider this item, last one, in the knapsack. We'll consider this in the knapsack. But it can only be considered whenever the weight of that item is less than the capacity that we have, right? Hence, it cannot be considered whenever the weight is greater than the capacity. So this would this means that the knapsack cannot accommodate this item. Hence, the only possible choice that we have is to not include it, which would be by making the choices from n to n minus 1 state. And in this case, we are not considering it in the knapsack. Okay, next up, we have two choices to make, either to take it or don't take it. If we take it, we will gain a value of that particular item, which would be this term, and the rest of the function would now make choices for the rest of the items. We made choices for this element. Now the elements that are left are beyond this index, and if we have taken this, the capacity for the next items to construct would be reduced by the weight of the item that we already took. So if we took it, initially the capacity was C, now it has changed to this value, and the weights are just for references. And if we don't take this particular element, in that case we don't need to consider any value and start making the choices for the rest of the array elements. So since these are the two possible choices to make a subset, we will maximize the answer over both of them, and this will give us the final answer. Okay, that's it about this video. If you found this useful, or if you have any doubts or suggestions, do let me know in the comments. Thank you.